Hello, and welcome to yet another retro channel. Today we're going to be working on the analog board and the CRT for the Macintosh 128 or Fat Mac 512K. And that's all analog magic and not really my forte. So as is typical for me, I will make a few mistakes. I've actually already completed the repairs and I'm recording this after the fact, so I know what's going to be coming up. So sit back and enjoy and watch me fumble around and see if we can get the analog board, the power supply, and the CRT all working. Okay, so here is the analog board. It's already been removed from the chassis. If you want to see how to do that, there are plenty of videos on YouTube already about how to remove it. It's just 3 screws and a little bit of finagling. I've also already removed the cardboard cover that goes on the back. That's stuck on with foam double-sided tape. I've already removed that and tried to clean up some of the adhesive that was on there so that I can get at the back of the board. The first thing we're going to do is a visual inspection. I'm just going to look over the board, see if I see anything that looks burned, broken, check the capacitors for bulging or leakage underneath, and just give it a general going over to make sure that everything looks good. And I can already see one problem right there. That's one of those dreaded RIFA caps. So I'm going to have to change that out. Fortunately, I do have a replacement. That's a 1 microfarad X safety cap, and I'll be replacing it with an X2 safety cap. So that's right here. First quick check is the fuse. And the fuse is good. So we're good there. But let's go ahead and give this an inspection. I will bring the camera in closer so you can do this with me. Okay. Start up here. And again, we're looking for anything that looks burned, broken, cracked. Capacitors, we're looking for bulging or leakage underneath. So far, I'm not seeing anything. Still nothing. The contacts from the battery compartment, looks like there might be a little green on them from where the battery originally leaked, but whoever had this before took the battery out and cleaned that up to at least some degree. So I'm not worried about any of that. Still not seeing any broken components, burned components, or bulging capacitors. Everything's looking good. There's our RIFA. Okay. On visual inspection, the top of the board looks good. Let's flip over to the back of the board, and here's where we're likely to have some potential issues. Bring in the microscope for this. And what we're going to be looking for here in particular are broken or cold solder joints. This is the flyback transformer. So we'll be looking here. We'll be looking at where the connectors are. So this connector here is the connector that goes to the deflection ring on the CRT. This connector here goes to the motherboard. Did I get that backwards? Yes, I did. These pins are for the deflection yoke. These 4 pins here. And then these pins over here go to the neck board. So we'll be looking at those. Those often get cracked or have cold solders on them. So we'll probably just go ahead and reflow all of them just to be on the safe side. This has the footprint for 2 different flyback transformers. There's an inner smaller one and an outer larger one. So this could have 2 different size flybacks. This one has a small flyback, so they're pinned into the vias in the inner circle, but a lot of those connect to the outer circle. But everything else is looking pretty good. I'm not showing you every square millimeter of this board in the microscope because that would take forever. I'm going over it visually with my eyes. So I think our agenda for the first step of repair, or the first step of work on the analog board, is going to be to replace the RIFA cap and resolder or reflow the connectors. And there is our little RIFA cap. Now the epoxy casing on this is intact, so it wasn't in any immediate danger of blowing, but it would have eventually. Okay, so I did manage to pull the pads when I took the old RIFA cap out. So I've had to make a little modification and bend the leads to make contact with bits of the traces that I cleared with the grinder. So I just checked and continuity is good. So that RIFA cap is now in place. Right down there. So now it's time to reflow the pins on the back. And that's all the preventative maintenance. Now we need to find out if this thing is working at all. We're going to be checking the power supply portion first. Not anything to do with the CRT. So I'm going to make a couple of changes. First thing I want to do is I'm going to take the high voltage anode cap and I'm going to put it in a glass tumbler. Now, that's not perfect protection, but it's something. Better than nothing. Okay, so what I have hooked up now is I have the multimeter hooked up to the 5-volt rail. And because this is a switch mode power supply and we'll need a load to get it to regulate properly, I have a 6 ohm 40 watt automotive resistor in line with the 5-volt rail. That should, I think, be enough to get us to regulate properly. If we're far off on the 5-volt rail, I'll have to shut it off and figure out what's going on. If we're close, This pot right here should be a voltage adjustment. So I've got a ceramic tool that I can use to adjust that. I've got my gloves back on because once I plug this in, once I plug the IEC cable in, some of this will be live automatically. For instance, the replacement for the RIFA, the safety cap, and I think this is a safety cap as well. Those will be live, and a few other things will be live. And then, of course, once I turn the power on, there's going to be a lot of voltage going through various parts of this board. So I want to play it safe. I'm wearing my gloves. I'm wearing my rubber-soled shoes. I'm going to try to be careful with everything so I don't get a zap. But if this works, when I flip the switch, we should get 5 volts on the meter. So here we go. This is the first time a power cord's been plugged into this in at least the year that I've owned the machine. Okay, now as I said, some of this is now live. Let's see what happens when we flip the switch. Nope. We're getting clicking, which indicates that the power supply is shutting itself down because of a short or something. It could be my leads here. I'm not connected very safely. Who knows what's actually happening? Yeah, I could have had a short right there. Let's try to clean that up. Okay, let's give it another shot. Nope. So let's actually pull those all off and see if we're still getting the clicking. All the leads are now removed. Are we still getting clicking? Yep. All right, something is wrong with this board. And that's unfortunate because, frankly, this is analog magic and I'm not sure exactly what's going on. Could be a regulation issue, and I might not have had the resistor connected correctly. Let's go back over what I did. Well, I am going to have to do some research to figure out what could be going on here. Okay, that was entirely my bad. I didn't look at the schematics, and I presumed that the 5-volt rail was the one that had to be loaded. That is in fact not the case. If you look at the schematic here, this is the feedback circuit that leads to the regulation and the protection circuit. And it feeds, if you'll notice, off the plus 12-volt rail, not the plus 5-volt rail. So what I've done now is I have moved the load resistor onto the 12-volt rail, and I have the meter hooked up to the 5-volt rail. So if I turn it on now, and I have the voltage adjustment all the way at the lowest point, you'll see that we get 5.3 volts. Now, that's a little high, but that could be because that's not enough of a load. That's only, as I said, a 6 ohm resistor. So when we hook it up to the main board, we'll have to check the rails again and see what we're getting at. It's dropping down. It's 5.1, which is a safe voltage for the main logic board. So let's get this thing in some kind of configuration where I can test and see if it starts the main logic board and the CRT. We'll get a chance to see if the CRT is functioning properly. Okay, this is all a bit precarious, but everything is reconnected. I have the deflection yoke connected. I have the neck board connected. I have the main logic board connected. I have the ground that goes to the neck board. I have the chassis ground. The only thing, I don't have the disk drive in because that's not important right now. So I have the mains power connected. Let's see what happens. That's a good sign. Not getting anything from the CRT at the moment. Okay. Turn it back off. Turn it back on. Check for our 5 volts on the logic board connector. 4.48, so we need to go up a little bit in voltage. I don't know if you can see that, but we are getting our 12,000 volts on the high voltage. So we do have high voltage to the CRT. If it looks like we're getting anything from the heater. Well, you might or might not believe this one, but that was my bad too. In working on the analog board, I knocked off the knob that's attached to the brightness control on the bottom of the Mac, and at some point apparently I got that potentiometer moved to almost the minimum position. So now there we are. Now the geometry needs adjusted a little bit. It needs to be shrunk and maybe moved up a little, but apart from that, it's a working CRT, a working analog board, a working Mac. So where does that leave us? Well, we still have the internal and external floppy drives to deal with, and the keyboard, make sure it's all working. But by the time we get all that done, we should have a working Mac 128/Fat Mac 512. And we also need to look at the motherboard and reinstalling that 1 meg memory add-on card. I do have some ideas for getting that working properly, and that involves replacing the ROMs. So I'm going to try that. But for now, we have a functioning Macintosh. So I hope you enjoyed the video. Thank you for watching. Thank you for putting up with my mistakes. If you like the video, smash the like button and leave me a comment in the comment section. I love interacting with you guys. Share the video if you think others would like to see it. And if you'd like to support the channel, there are a couple ways you can do that. My Patreon and Ko-Fi links will be in the description, or you can simply hit the join button below to join the YouTube channel membership. So until next time, everybody have a great week, be safe and stay healthy, and I hope your retro adventures are as fun as mine. Thanks, and we'll see you in the next one. Shut this thing down now. Oh boy. Always my own screw-ups.